This is something, it's a continuation of the previous video number 7. I think you may treat it as 7A due to some technical problem. Now, I was trying to give you that this is an ideal case of this bouncing ball. You would never expect that bouncing ball to reach the same height once it is dropped, right? If I want to plot a velocity time graph for that, it keeps on, for example, this is the thing. I'm just drawing a line here and another line here. So that's how after the first bounce, I projected it up and then it will come down. Now, from this point, again you will get it. Again you will get it. Mind you, the slopes of all these things is same. There is a discontinuity in the graph. So this is generally given in terms of a dotted line. This is how a velocity time graph looks like. Get the point? Supposing I want to draw speed time graph for the same thing. This is velocity, this is time. Now I want to take speed. You know, speed can't be negative. This one. Now, speed time graph, how do you plot? For example, till this point, this one. So I projected it up, this speed has become 0. Then the speed starts increasing again. I've projected it up, it has become 0, and now it goes on increasing. So that's it. You can very clearly draw like this on and on and on. The speed can never be negative. Remember, sometimes they'll ask you to find out the odd man out, which graph is not possible. That's how they ask. Now you have to understand that speed cannot be negative. Therefore, this kind of a coming below this doesn't arise here. If at all it is shown, that is a wrong case. Now, this is a case of a bouncing ball that you have seen. Now, the velocity time graph we have seen quite a few cases. Number 1, dropping a body. Number 2, projecting up. Number 3, it is projected from the top of a tower. That's number 1. Now, the next graph that we can look at is acceleration time graph. Acceleration time graph, I take acceleration here, time here. Suppose if I take this, that is uniform positive acceleration, and if I take here, this is uniform retardation. That's all. In case you come across a variable acceleration like this, there is a rate at which this acceleration changes. It may increase, it may decrease, anything is possible. Now here slope is given as jerk. Jerk is nothing but your rate of change of acceleration. We will not get into that, but variable acceleration cases we have already dealt with in our analytical analysis. All right. Now another very important point here is area under the curve with the time axis. What does this give? This gives change in velocity. This is important, not the velocity. It will always give change in velocity in this case, AT graph. Now in many cases, they'll ask you correspondence of the graphs. correspondence of the graphs, or they may give. So I'll give you one model. For example, I am plotting, say, a position time graph. Position time graph. How, for example, if I am drawing one, I am drawing another like this. There are two graphs. You know that in the case of a position time graph, the slope is nothing but your instantaneous velocity. So if I say this is VA, this is VB, which velocity is more? Obviously, more slope, more velocity, therefore VB is greater than VA. Fine. Supposing in the case of position time graph, two lines intersect. Two lines intersect. I'll show you how this happens. Probably one is like this, A. Another is like this, B. Okay? That means at the same time, two bodies are starting with the uniform velocity along the same direction. Now, this is the ahead of this body. So you know that here, because slope of B is more, velocity of B is more. Here is a body, here is another body. Now this is A, it is going like this, it is going and then catching it up. It is going fast and catching it up. So the point of intersection, remember, only in position time graph. Now I just want you to remember this. Everywhere you come across point of intersection, do not try to interpret it that way, except in position time graph. In position time graph, the point of intersection is the point of meeting of two bodies, or point of collision, or where the two bodies meet. Likewise, you can visualize. So here, now it is possible that it would do it at one point, or look at in my subsequent example. For example, this is a constant velocity. Look at that. This is B, this is A. A is going with the uniform velocity, and B is going with, say, some acceleration, because it's a variable slope, variable velocity, therefore acceleration. Now it is meeting at 2 points. It's meeting at 2 points. Where do you come across this? Now, see this, supposing I am considering this as the bus, A as the bus going likewise. Where is the bus? For example, I am looking at this. This is the bus, and this is A, the person. Bus is going with the uniform velocity likewise, and this person starts accelerating. The person starts accelerating, and he will go and catch the bus at one point, that is this one, C. He will catch it. He may get into the bus, presuming that he misses the bus, and he continues to run. Remember, at point C, at the point of intersection C, look at the velocity of the person. The velocity of the person or the slope of this is much less than this slope. Just because this person catches the bus doesn't mean their velocities are same. Doesn't mean that there is any relation between the accelerations. Only thing is they are both at the same point. That's it. But since he misses the bus, but bus moves with faster, more velocity, so he still continues to accelerate, and at one stage he will catch up with the bus, and that is your C dash, maybe at that point. And by the time he reaches C dash, look at his velocity. That velocity is much more than that of A. Now, when you have 2 points, what does it convey? That this person meets the bus twice in its path. That is the meaning. And meeting question arises graphically only in position time graph. I want you to be very, very, very careful about this. Alright? Now, once we understand that two cases, for example, if I take VT graph, now for example, as we have taken this is A, there are 2 points of intersection. Remember, what do you mean by point of intersection in a velocity time graph? You cannot interpret that the 2 bodies meet there. It is impossible for you. And the similar way here also you cannot interpret that the 2 bodies meet at that point. Meeting of the 2 bodies takes place only in a graph. You want to interpret it from a graph, it takes place only in position time cases, not in velocity time graphs, nor in acceleration time graphs. Now this is an important point that you should be aware of. Alright? Now, if you look at whatever I have discussed so far in 1D motion, 1D motion I have discussed, I am trying to give a recap of all that I have discussed in 1D motion. 1D motion, I was trying to look at uniform accelerated motion or variable accelerated motion. Variable accelerated motion means A is a function of time, A is a function of r, or A is a function of velocity. In each of these cases, I gave you one example and then worked up. In this case, you will give A is equal to constant. Now, this is important. Now, if it is constant, you have your own way of working out. You can directly write V is equal to U plus theta. But how do you write here? V is equal to U plus integral A dt. Now, S is equal to ut plus half a t square. And how do you get it here? S is equal to integral V dt. Now, this is V square is equal to U square plus 2as, and here V square is equal to U square plus 2 integral R. That's all you have learnt in this in 1D motion in a nutshell. Now, if you recall, I tried to give you how to get distance in the case of 1D motion. I told you that you can't have a direct formula for getting one distance in most of the cases. But in 1D motion, there is a way to work it out. I already explained it to you. And then based on these equations, I have tried to give you a few graphs, not all the graphs, a few graphs for position time, distance time, velocity time, speed time, and acceleration time graphs. I've just tried to give you, and this is the information that you have learnt in 1D motion. Alright? Now, I want you to be very perfect in writing these equations whenever certain information is given. I'll definitely give you 2 to 3 examples here and then look at it. Now, let me give you, here is a vector notation. I'm just giving a case where this is 30i plus 40z. I want you to be very, very careful in following this lecture because I'm trying to combine the 2D motion with vectors. And you can see how easy it is for you to work out each of the problems that you come across. You need not have to memorize even a single formula from your projectiles. So before I discuss the projectiles, I want you to be thorough with writing expressions in this fashion. Say for example, there is an initial I, J, these are the mutually perpendicular directions. Now, as far as I am concerned, if A bar is given as, let us say 10I plus 5J, or I will say minus 5J. What do you mean by this? Now, this is an independent direction, this doesn't depend on that, this doesn't depend on this. By giving like this, what do you mean by mod u here? You are aware of it. Every time you want, you get 30 square plus 40 square, and that is equal to how much? 50 in this example. In a similar way, you can get mod A as well. 100 plus 25, say 125. And then, what angle does it make with I? So, you have tan inverse 40 by 30. This is the angle that this velocity makes with I. What angle it makes with J? Tan inverse 30 by 40. In a similar way, this also. But I just, although I explained it long back, I will explain this again to you. Now, if you plot like this, right, I and J, now this is 30 units along I, 40 units along J. So, this is your initial velocity, 30I plus 40 in the J. This is your I direction, this is your J direction. And what is the angle that it makes with I? The suffix I stands for with which direction this is making the angle. It is theta I. So how do you write tan theta I? Opposite side by adjacent side, 40 by 30. Therefore, this is tan inverse by 40 by 30. The moment a vector notation is given, now you know its magnitude, you know the direction, either with one of these axes, either I or J. So, when I give 30A plus 40J, the entire information is with me as far as initial velocity is concerned. In a similar way, acceleration is also given, that is also with me, 10 and 5, right? So, under root of 10 square plus 5 square, like that's the magnitude, the tan inverse minus 5 by 10 is the angle with I, tan inverse, and tan inverse 10 by minus 5 is the angle with J. Likewise, you can interpret, alright? So, while writing in vector notation, we are aware of the magnitude, we are aware of the direction also. Now, the important problem comes now. I want to get V at a time t. Now, how to get this? Now, since these two are independent, I want you to work out this as 1D motion. I want you to work out this independently as though this is 1D motion. Just write the appropriate sign that you get there. For example, how do you get it? What is initial velocity? 30. And is this acceleration constant? Yes. So which formula you will use? E is equal to U plus AT. U30 plus AT. All this is I. Along I, because I have to indicate. Plus, what is the velocity expression? Again, what is velocity here? I'm sorry, acceleration minus 5, constant. So, we again use, what is initial velocity in this direction? U plus, I'll put minus 5t. A is minus 5, so you get it. But the whole thing is in the direction of J. Therefore, I'll put that J factor there. So that is how I'm going to write this. Now, for example, I want to get the displacement at a time t. Now, generally, I take along I, displacement is x. I take y as the displacement along the general symbols. is equal. How do I write x? Treat it as displacement, and this is initial velocity, this is acceleration, time is t. So ut plus half it square because a is constant. So how do you write? 30t plus half 10t square I. Got it? Plus here. How do I write? Again, acceleration constant. So s is ut plus half at square. Therefore, 40t minus half 5t square. I already put negative sign there. So I got this. You may there give t is equal to 2, t is equal to 3. You substitute all that here, and then you will get what is the total displacement. If you want to get under root of x square plus y square, you can give it. Or if they want to know what angle does it make with I, you can give. What angle does it make with j, you can give. Anything that is possible when you write down in vector notation. Right? So now you got it. Now then finally, if I have to write v at appropriate x comma y, you use that formula v square is equal to u square plus 2as. So v square plus 2as means under root of u square plus 2as, because a is constant. What is this? 30 square plus 2x. Now the whole thing is along I. Be very careful of how I am writing this. I am writing those standard 3 equations. Since it is constant, acceleration is all the more easy for you to write down these expressions. And now coming to this, don't forget to write the square root here, because I can't write square here. It's a vector notation symbol. So again, u square 40 square plus 2a, what is yes here? Y. And the whole thing is along j. Purposely I took time to explain all this, how to write this. Now, if you adopt this way of writing, I can tell you most of your problems in the case of projectile, the case of 2D motion, you can solve it very easily. Although I am at the moment looking at only elliptical 2-dimensional motion. But individual to 1 dimensions I am combining. That's all I am trying to do here. Hope this concept is clear to you. I'll give you another example, but with a little more complication. How is that? Let me give, as before, say 30i plus 40j. Some units I am throwing it there. Now I will give minus 10j. When nothing else is given here, what does it mean? 0i. I'm purposely putting 0. You need not have to put it. See, we in India have certain conventions, and unless you see those values there, we get perplexed. So I just want you to understand various ways of interpretation. Forget about it. You have a constant acceleration, incidentally 0, means this part of the velocity is uniform in I direction. That means the value of velocity will not change. How much is that? It remains 30i, and similarly here also it remains 30 because velocity cannot change along I because a is 0 in that. What about this? Same as before. Is a variable or a constant? It is a constant. Therefore, how do you write that? As you have done it before. U plus at, that means there is a negative sign, therefore I am putting minus 10t there. That's it. The rest is very simple. As before, I am putting this so that you won't ever get confused that conventionally I am taking along x is the displacement, along jy is the displacement. And as far as this next is concerned, x, how do you get it? Ut plus half it square, that part is 0. Therefore, 30ti plus. I hope this point is clear to you. Okay? Now, next is 40t minus half 10 t square. Always put it in the bracket, and that is j. Same as previous case. But then in this case you will get a square root there because v is equal to under root of u square plus 2a. Therefore this is 40 square minus 2 into 10 into y. The whole thing is along j. Now previous case both accelerations are present. In this case, only one acceleration is present. Even then, I am able to take it. And you can very clearly see that there is an angle between velocity and acceleration, which is either acute or obtuse. Therefore, this motion is bound to be two-dimensional, not one-dimensional any longer. It's clear to you? Now, I go to a third example. I want you to understand, to write in this fashion because you don't come across these things in any textbook. And you will appreciate this at a later date when I give you all the projectile equations, etc., how easily you can get those answers. Now I go a little deep, 10i plus 12tj. Look at that. Look at that. I have given an acceleration which is constant in this direction but a variable in this direction. So while writing the equations you have to be very, very careful. And this being constant, as I told you, whenever you write this, do not look at that. And whenever you write this, do not look at this. Then you can easily do. Now let me treat it as 1D. So V is equal to U plus AT because A is constant. Now here what do you do? Because it is a variable, V is equal to U plus integral A dt. Now remember, U plus integral 12t dt. J. What is 12t integral? You have to find out. 12t square by 2, that is 6t square, and whatever the time limits are there, you can put and then work it out. So that is how you have to write this. What do you get here if I write the same thing? Or plus how much you get? 40. This will be 40 plus 6t square j. Integral 12t is 12 into t square by 2, 6t square by j. Now how do you write your S? As I told you, when you write this, do not look at that. Since constant acceleration, ut plus half a t square I. Next, in this case, it is a variable velocity. So, integral 40 plus 60 square dt j. Integral 40 plus 60 square dt. I write it again here. 30t plus 5t square I plus 40t 6t cube by 3. T square integral is t raised to n plus 1 by n plus 1. 6t cube by 3, that will be 2t cube j. There are no complications. You don't know, you need not bother how the body is moving. Simply blindly do it, and then interpretation comes much later. So what do you do for this? You can ignore it because 12t means you cannot write how to get this, etc. There is a problem, so I don't want you to get involved in any complications at this stage. So this is how you are going to write. There could be a combination of a constant acceleration and a variable acceleration. You understand that? Now let me work out Now, in a different fashion, I rewrite this. So I am writing these two information are given. I can automatically write these things. Now, this is the important point. Now, for example, look at that. I am now taking a case where a body is projected at an angle theta with say I, this is J, this is U. Therefore, the component of velocity along I is U cos theta, component of velocity along J is U sin theta. And if this is horizontal direction and this is vertical direction, then my acceleration is always downwards, and close to the surface it is a constant value. Therefore, how is acceleration directed? Opposite to J, that is minus Jg. Now, based on this, if I write the expressions, this is U cos theta plus J is U sin theta. I have written in component form. Acceleration is only along minus J, along I it is 0. So I am erasing this part and now writing J U sin theta. So this is my so-called vertical component. This is horizontal. Don't take it as a horrible component. It is a horizontal component. Now A bar, as I said, nothing in the I direction, but in this minus J direction you have a constant value. As before, treat the problem in a similar way and then try to write down these expressions. How do you write down those expressions? As I have said before, since acceleration is 0, there won't be any change in this. But in this case, J U sin theta t, U plus AT, that is minus GT. A is minus G there. In a similar way, how do I write it? I U cos theta t plus J ut plus half AT square. Ut here plus is minus D, so you have ut minus half AT square. And then what about this here? As before, this is U cos theta because acceleration is 0, velocity along x-axis doesn't change. Plus here J root U square sin square theta minus plus 2 minus G, and this is Y. Y is the displacement in this direction, X is the displacement in this direction. Now you know how you could write these expressions. Very simple. Every time a problem is given, split and write it in that vector notation so that automatically you can write all these expressions. It has its own utility. And how this is going to be useful, I am going to tell you very soon. For example, I am erasing, let it be, I'll erase it because it's too small a board. Right. Now, whatever you have drawn here, written down there, with this you can play. For example, I give you this case, this is ground, level ground. I am projecting a body along the horizontal direction, and this is your vertical direction. And now this particle, intuitively you can say it will go and then fall in this direction. It appears like this. What is this shape? We do not know. But when you throw something, a javelin or a shot put or something or a ball, you know that it goes up and then comes down. Even the cricket ball, you see when he hits it up, it goes up and then comes down. What shape is this? A circular? Is it hyperbolical? Or is it parabolical? We do not know. We will try to find out what it is at a later stage. But at this point of time, I just want you to understand that remember, acceleration is always downwards. It's a constant acceleration, and therefore, initially, this is u sine theta, the vertical component. Now, I am erasing this part. After certain stage, if you go, what is the horizontal component? U cos theta. If you come here, there is no change in the horizontal component. Why? Because there is no acceleration in this direction, there is no change in the velocity. It remains u cos theta, but this will be reduced. What is its value? U sine theta minus dt. This is what you have written in your equation. Second expression, u, a, v. How do you write? How did you v write v? U cos theta plus j u sine theta minus dt. I hope you have understood this. What happens here? As you go like this vertical component goes on decreasing and becomes 0, and it starts its reversal. By the time it reverses, that is how the vertical component of velocity is going to vary, likewise 0. But mind you, your horizontal component will always remain the same. There is no change anywhere. I repeat this point a number of times because there is no acceleration in this. If somebody asks you, does the velocity change when the ball is projected like this? Your answer must be yes. Although one component remains the same. All this is in the absence of aid resistance. We are not going to look at any complications of that nature. Now, this is how you can visualize. Now, one by one, if I look at it, this is just a graphical representation of whatever we have represented in this case. Now, from this, there are certain standard expressions that you come across. I repeat that here, I u cos theta, j u sin theta. Now, there is no hard and fast rule for you to write cos theta here all the time, sin theta here all the time. All depends on theta is given with respect to which direction. This is theta with respect to horizontal. If theta is given with respect to vertical, this could have probably become sin theta, and this could have become cos theta. That is the, so although we do write in our subsequent equations also in terms of cos theta, never ever get carried away with this. Every time a problem is given, you have to be watchful whether the angle is given with respect to the horizontal or with respect to the vertical. And my A bar as usual is, I'm just looking at the previous case only. So V bar, I u cos theta, j u sin theta minus dt. And similarly, S bar, I u cos theta t plus g u sin theta t minus half g t square. Likewise. So you have even the other one also. Let me write it, lest you may feel why I have skipped. Because I'm not going to use this much. I generally avoid. Right, okay, this is okay. These are all the equations. I ask you suddenly, what is the change in velocity in time t? Change in velocity in time t. Final velocity minus initial. Now this minus this, u cos theta cancels. In this case, u sin theta also cancel. So the answer is minus j gt. Minus the j plus j minus j is our creation. What does plus j mean here? Plus j means vertically up, minus j means vertically down. Therefore, this implies gt downwards is the answer. In 3 seconds, what is the change in velocity? 3g downwards. That is how you have to give this. I hope this point is clear to you now, right? Now, they may ask, this is first case, change in velocity. Second case, they may say, when is the velocity perpendicular to the initial velocity? Now, this is another important point. Various cases, they always talk about perpendicularity condition. Whenever they say perpendicular, immediately what should enter your mind is the dot product. You remember we learned dot product and cross product in vectors? So you have to use dot product in. How to use the dot product in, you know very well. How to work out dot product, you know very well. But then to prove that these two are perpendicular to each other, so your dot product of those two must be equal to 0. That is the case. For example, u bar perpendicular to Vt, you want to know the condition. This implies u bar dot Vt must be 0. Dot product means, say this is I dot I1, u cos theta into u cos theta, u square cos square theta, and this is plus u square sin square theta minus gt u sin theta. Now this implies this is u square, so when u gets cancelled, you could see that. Therefore, u by g sin theta is equal to t. You see, if you draw the graph and then try to find out when is this perpendicular, what conditions you have to use, it becomes very complicated graphically, pictorially. So what we are trying to work out here is very simple. I just take this and then get the dot product, put it equal to 0. Therefore, t is equal to u by g sin theta. Now, this is how you will try to work out using this. Of course, there are many more such things. I will continue this in my next lecture. Thank you.